Is being
right around
recorded.
noon. Okay, well, let's get things started here. I really do appreciate everybody joining today. I know, I'm sure all of you are dealing with some type of crisis within your IT, and hopefully not at home, but with the work from home policy, like Drew mentioned, we would typically be in an office, but not today. So you get to see my working condition that I'm normally in if I'm not visiting customers. But let's kick it off. And I'd like to have the session be interactive. Nobody is muted by default. If you wouldn't mind muting your line, but if you have any questions, please feel free to unmute and ask any questions. Or alternatively, you can enter them into the WebEx chat, and Drew Keller is monitoring that, and he'll jump in if there's any questions. Thanks again for joining the Technical Advisor Program for this quarter, quarter three. I'm Jason Powell. I'm the systems architect on Metro Philly Select. I do see some of my customers out there, so thank you for joining. Um, what we're going to be reviewing today on the TAP call is the Catalyst 9800 series wireless controller. Now, most of you have probably had presentations around Wi-Fi 6 and the new controllers and the new access points, and a lot of it's slideware, and a lot of it takes a while to cover all that content. So it doesn't really leave a lot of time for an in-depth demo or tour of the user interface. But the one thing that we talk about consistently is that, yes, the Catalyst 9800 controller is the next gen wireless controller. It is iOS XE based. But what I want to do today is provide a tour of the user interface and show what configuration looks like on the 9800 wireless controller. A lot of you may have experience with the AirOS controllers that are out there and the UI that's associated with it. And maybe there's some hesitation that um, the 9800 is going to be so drastically different that you'll just continue to use what you have until you really have to consider migrating. But hopefully today you'll see that the 9800 is a little bit easier to use even than the existing AirOS controllers. Let's start off. Why did Cisco develop a new wireless controller and new access points? And a lot of it is to meet the demand of Wi-Fi 6, 802.11ax. But we also created a new controller because AirOS was based on its own software, uh, not very user-friendly from a CLI perspective, not necessarily limited in its features, but when you start looking at what Cisco is doing with intent-based networking and controller-based networking and campus fabrics, we have DNA Center that sits on top of a lot of the LAN automation that's available today. Also sits on a lot of the assurance. Well, when our campus portfolio is pretty much all iOS XE based from our 3800 series switches on up, our ISR 4000 routers on up, the wireless side became a little bit of a long pole in the tent in that how does a centralized controller like DNA Center program the network if the entire network isn't using the same OS? So Cisco made the decision a few years ago to move our wireless controllers to iOS XE. Along with that, we kept a lot of the same features and all of the same features and added a lot more. But from an ASIC perspective, Cisco develops all of our own ASICs for the most part. That's no different on the wireless access points. We have our ASICs that provide features like clean air to squelch interference on a particular channel, uh, off-channel scanning for radio resource management. It's basically the ASIC acts as its own dedicated radio to keep from using the 2.4 and 5 gigahertz radios that are in the access points. Okay, physical and virtual. With the Catalyst 9800, we actually did not change those form factors. We still have the form factors of virtual that can run in any of the public cloud environments, well, Amazon and Azure for right now, and as well as VMware and Hyper-V. But we also have our physical appliances as well. At this point, we've actually reached the physical parity from a sizing perspective with our legacy uh, controllers, powered by iOS XE. Extremely important from that automation standpoint from DNA Center. So just so you know, Prime Infrastructure is still able to discover and manage all of the Catalyst 9800 and Wi-Fi 6 APs. But Cisco's direction really is to have this integrated campus network through DNA Center. And uh, the presentation today and the demo today will not focus on DNA Center. There's a lot of work that we have to do in our lab to get the 9800 integrated into DNA Center, but we will be doing a follow-up session for everybody so they could see what the advantages of assurance, of Wi-Fi reporting, of application sensors or client sensors. It's not something we want to skip out on, but it's from our lab perspective, we're not ready to demo that yet. And more importantly, if you don't have DNA Center today, or maybe it's not on your roadmap, but you do have an initiative to move towards Wi-Fi 6, well, then we want to make sure that you're comfortable with what the actual controller looks like. Okay, one last thing on this slide that I'll talk about are the APIs. And the APIs are key. So within iOS XE on our routing and switching platforms, we really took an initiative about 4 years ago to integrate APIs into iOS XE because the kernel is virtualized, or we virtualize on top of the kernel, and we're able to spin up containers. We're able to spin up VMs if you really wanted to, but mostly containers. We're able to write an API for the entire iOS XE that you can make API calls against using netconf and Yang templates, JSON formatting. There is some XML. So we're not going to be going through the APIs today, but just know that the APIs are key. And again, it goes back to having this iOS XE foundation that we want to be able to access every device, regardless of what function it serves, via the same way and the same type of APIs. Okay, we're not going to spend a lot of time on slides. I'm going to use slides as reference, but what I really want to show, let's get into the heart of it, is the controller itself. And actually, one other point that I would like to make here is that with the Catalyst 9800 series controller, we're not asking, or the new APs, we're not asking customers to forklift their entire environment. We'll talk about how you could have seamless roaming between the 9800 and Air OS, but more importantly, the APs that are out there. If you have legacy APs, let's say from the 2700 or 3700 series on up, on your Air OS controller, like a 5520 or 3504, those will still be supported on the Catalyst 9800 series controller. The thing is, the AP itself, it has its own base software, but it doesn't run iOS XE or it doesn't run Air OS. That's purely the controller. And then the controller has its own mechanism for pushing down configuration and policy to the AP, regardless of regardless of if it's Air OS or 9800. The AP is set to understand communication from either generation of controller. So I think that's a big point. And just to further reiterate that point, here's our supportability matrix, our compatibility matrix. This is for iOS XE, the latest, but you can see we support all of the 9100 series all the way down to the 2700, and actually some 1800 and 1700 series as well. We also support some of the embedded access points. So you could see that if you deployed a 9800, you have a path forward for some of the older APs. Unfortunately, the 2600 series, they're not supported, so you would have to do something with that. On the flip side, the Air OS controllers that are out there that are currently, we're still releasing software for them. They're up to 8.10. You see that on the Air OS, we actually have the 9130s, 9120s, basically the 9100 series. So let's say that maybe you're not ready to move to the 9800 series controller, but you want to prepare by starting to purchase some of the newer APs. You can. The biggest caveat there is, of course, it has to be a version of software that supports it. And most of the software is 8.9 and above. Okay, there's a whole other conversation about compatibility of controller software and mobility, and we will talk about that, but we'll save that for a little bit further down in the presentation. So let's get to the meat of what we wanted to show today. What I have up on the screen now is the Catalyst 9800 series wireless controller. You can see the interface is more similar to Prime infrastructure. Cisco has a conscious effort to standardize all of our UIs, so you don't have to go everywhere and figure out how to use, one tool versus the other. We're not going back and changing the Air OS, but moving forward, this is what our UI will look like. All right. Everything is easy to access. We have a search menu. We have our dashboard monitoring. You can see the pop out and it gives a good overview of everything you can click on. We don't do sub menus here, so you don't end up having 10 menus across the screen. It's very clean. All of your configuration parameters, we're going to talk about some of these, administration and troubleshooting. So we're going to go through each of those tabs and we're going to go through some of the highlights. Let's start with the dashboard and monitoring. So the dashboard is really not too much different from the Air OS controllers. You have everything listed here, what wireless LANs you have, what access points are registered and active. You'd see a quick view of your rogue APs if there's any rogue clients that are trying to join. We could see that as well. You could look at the CPU and memory for the controller itself. You could look at the radio count, and you could look at some system information for the controller itself. Now, to tell what version of software you're on, it's simple. It's right up here in the top left corner. So we're running 16.12.1s. All right. If I were to drill down, let's take a look at the access point. Okay. You can see here, we only have, because this is our lab was recently moved to Island, New Jersey from Morristown. We're still in various stages of setting up the lab, but for the most part, it is active. The only thing we don't have for today are clients that are registered to the access point, but none of the demos really go down to the client level. By the time we do get DNA Center integrate, or the wireless controller integrated with DNA Center, we do anticipate having wireless clients, and we'll be able to go through some of the cool features like packet capture, intelligent packet capture, and client assurance. Seeing if there's issues from clients joining the network. But for right now, the demo goes as far as the AP itself. All right. So notice if I were to click on access points, I go down to monitoring. So it actually brings you to an area where we're reducing the amount of redundancy or duplication by just having pointers to where everything really is. If we go to WLAN, it takes you down to the configuration. All right. So now let's go to monitoring and let's look at AP statistics. All right. Here's our AP, exactly where we went from the dashboard. And let's go to join statistics. All right. It tells you the number of APs and where they're joined to, information on the MAC addresses, for the radio, for the Ethernet interface, the IP address that I got for DHCP. And then if we go to general and we click on the AP, one of the more important pieces is the 360 view. Now, 360 is something that we have extensively in DNA Center for basically every section of assurance or device management. Everything has a 360 view, and that's meant to show the health of the device and what's happening on the device as much as we can. So you could see by going to by clicking on the AP, again, you get a lot of that information, IP, MAC addresses, what software version the AP is running, that's important. And then the channel utilization. So what channels are utilized, what channels are currently in use, 5 gigahertz versus 2 gigahertz. So it gives you a quick way to view what's going on with the AP. Honestly, there's not a lot of interesting stats on these other tabs, so I'm not really going to go through these other stats. But just know, as you get more in depth and you grow your wireless environment, there's a lot more information out here to be had. Okay. Some of the other things that monitoring has, we could look at clean air statistics. We may not have clean air enabled right now, but that's where you would look at if you're looking for anything that's any squelching that's happening or any interference. You'd also go here to look at CDP neighbors, the ports, the system information if you wanted to. Information is good because it gives you more in-depth memory, CPU utilization. It tells you what's the wireless interface, gives you a management summary. So are you doing SNMP, HTTP, HTTPS, and then redundancy. So it actually, I don't have an HA pair here. I do have a mobility group. But if you were to look at redundancy to a secondary controller via the redundant ports, you would see that information here. There's a lot of good information. All right. Now, we're not going to go through every option on here because we'd be here till tomorrow. I want to show what's most important. And honestly, one of the most important changes for the C9800 and iOS XE based wireless is the configuration of the policy. So we've really worked to streamline the configuration of the policy. We've made it more modular, and you'll see that we'll actually do a walkthrough of the policy, but you'll see that we do make it a little bit more intuitive and guide you along the path. So in AirOS, if you're used to configuring in AirOS, you're familiar with all the different policies that you have, and you have they're more they're less granular, they're more rigid policies. So for every WLAN that you have to every WLAN that you have to configure, you also have to configure your switching policy, your networking policy. All right, AP groups may or may not be used depending on what the AP join policy is, and if you have different locations, you may have different join groups. But you can see that there's network policy, the site settings for the APs, site-specific policies, and the RF parameters. So there's duplication here between these RF parameters and what's in the RF profile. Flex group remains pretty much the same, but again, when you go and configure, you basically have these groups, and not that you're limited in the granularity of the configuration, but you're duplicating a lot of it. And what Cisco really aimed to do was make the configuration more usable, reusable, which means you configure once and then you reuse some of those policies. So if we look, what did we actually decouple? Well, we went, I think this is moving a little too fast. There we go. Yeah. So, okay, this is just going to build out on its own here. So what we did was we took the wireless components of the WLAN and made them their own profile. We then took the policy, which is the switching and network, made that its own profile. These are now independent of each other. All right, you have an AP join profile that you could set for your main location. Then you can have different AP join profiles for remote locations, and the flex profile. Right? But what we did was it would be a lot to apply each of these policies to each AP or group of APs. So what we did was we rolled these policies into the concept of tags. Okay, so now you create a policy tag where that contains your WLAN and your policy profile. So let's say that you had 5 WLANs, but they really were all going to be centralized switching. They all had the same network policy. Well, you could just configure that one policy profile and reuse it for every WLAN. All right. The same for the AP join profile. So you may have different APs or you may have different requirements for the AP to join per site, but then you may have the same flex profile. Now it's more modular where you can change that. And then again, your RF profile, you notice how we moved some of the RF out of the AP group, and now the RF profile is wholly rolled into the RF tag. All right. And the APs, when you go to apply to an AP, you see 3 tags: site, policy, and RF. And that's what we're going to demo today. All right. Are there any questions so far that anybody has? Okay. Well,
In the chat room here.
okay, no problem. If there is, feel free to jump in. All right. So when we go to configuration, all right, it's I just talked about all the tags and profiles. Here they are. It's pretty daunting to have to go through and remember which wireless LANs and policy profiles you need to create. So what we did was we actually have 2 wizards. I know a lot of people don't like wizards. They don't like to talk about wizards. But we've done it a little bit differently, and we've made them more interactive. All right, so we have a basic wizard, which I'm not going to spend a lot of time here, but basically this allows you to put in a location name. So type 1, location type local, client density. This is RF profile specific, so you'll see we have canned RF, but you could select, what is your typical user density, your client density? Is it low, typical, or is it high? Is it high like a conference room or like a training room or something like that? We then go to wireless networks, define your WLAN parameters, and then AP provisioning, your AP join profile. You would apply everything to the AP list. Honestly, it's really simple. It's for if you just want to quickly turn up a wireless LAN or an SSID, you would use this. But the reality is, most people will probably want to go through the advanced because it gives you more options. So I'm going to go to the advanced configuration. All right. Now, what I showed you was on a slide about how all the profiles create the policy tags and what profiles belong to which policy tag. Well, now you actually don't have to refer to a PowerPoint slide or go out to CCO and find it. As soon as you click on the advanced wizard, it's right here, and it actually shows you nested what profiles belong to which tags. And then they actually go through the phases. So you have your design phase and then your deploy phase. All right. It explains what this icon means and this icon means. But if you notice, I can't click on anything here because honestly, this would probably be just as confusing as going to the configuration tab. So this is where the wizard kicks off by clicking on the Start Now tab. All right. When you click on the Start Now tab, you can see you could look at any of your wireless profiles that are out there, or you could create your own wireless profile. So we're going to create a new wireless profile. All right. If I wanted to, in the background, you kind of see the wireless profiles that are out there today. The wireless profile is where you define your SSID and the security for clients joining the SSID. So I'm just going to call this Tap Today. The profile name will be Tap Today WLAN. All right, so you have to have a profile name because the profile is what you associate to the tag. But under the profile is the SSID. Automatically assigns a WLAN ID, and I want to enable it. Now, if we go to security, so layer 2, this is where you select your client authentication and encryption modes. So you have WPA2, we have WPA2 and WPA3. I'm just going to leave it at WPA and WPA2, but we fully support WPA3 if you have clients that require that. All right. You have multiple encryption mechanisms. You have the auth key management. So you can do pre-shared key, but I think most customers have some type of identity services in the back end, whether it's hopefully it's Cisco Identity Services Engine, maybe ClearPass, maybe something else. But for the most part, I think customers are doing 802.1x and letting this the identity server handle client authentication. So I'm going to leave that there. There isn't much for layer 3 and the AAA piece. The AAA piece is actually not what you think. It's more for a wireless authentication, a different type of authentication, but it's not for clients authenticating. So we're going to leave that default. And I'll show you the AAA configuration. But basically, when somebody associates via and they're prompted for 802.1x, the wireless controller will send it out to your services engine. Then we have some advanced. There isn't really much here that I'm going to dive into. This isn't meant to do a deep dive into what every parameter means. But I think what's important here is the 802.11b BSS transition support. So that's something with Wi-Fi 6 that helps clients align to the best access point, but it also helps the controller to shift user clients from one AP to another if they find that there's better signal or there's maintenance that's coming up. And then one of the most important pieces here, again, are the 802.11ax configurations. Your uplink and downlink OFDMA, which gives you more bandwidth, the multi-user MIMO uplink and downlink, which is a much more efficient way of utilizing all of your radios and antennas, and then target wait time and stuff like that. So yeah, this is where you would go in your policy to configure anything like that. All right. I'm just going to stick with the profiles that I created yesterday. So I have like tap WLAN, but now that part is finished. So I created the WLAN profile. So now let's go to the policy profile. And like I said, this is really the area where you do where you define your switching policy. Do you want to do centralized? Do you want to do remote switching? If you were running TrustSec, this is where you would configure options to enable TrustSec and enforcement. So I'm just going to call this tap profile. I'm going to make this enable. All right. And we'll go through what each of the screens are. So if you wanted to do radius profiling for your users, you could do that on this screen. The VLAN, so since we're doing centralized switching, we have to define the VLAN. So I have a client VLAN for the tap session. If I had a guest, I could create a guest interface and have that pipe directly to a DMZ. And I would select that VLAN for guest. But for this, we'll create client VLAN. We do have wireless LAN access lists and URL filters. URL filters we're not going to go into, but just know that you could do some application profiling and blocking, like on your guest network. If you wanted to cut off YouTube, you could define a URL filter for YouTube, and then you could rate limit it down to whatever. It's kind of brute force, to be honest. There's much better mechanisms, whether it's within DNA Center or maybe Umbrella. Because there are integrations with Umbrella. But for the most part, if you need to do something quick and dirty, you could define a URL filter. All right, QoS and AVC. So we do support NetFlow, we support NBAR, and we support application visibility. I'm actually going to show you this after, well, I'm not going to show you the actual applications, but I'm going to show you how you would use the search to find application visibility, because it's there, but you might spend a little bit of time like I did looking for it. Right? For mobility, if you had an anchor controller or a guest anchor, this would be the section on the policy profile where you would provision your anchor controller. All right, and it's as simple as, all right, I know about all these other controllers that are out there. This is the anchor IP. I'm going to move it over and enable it, export anchor. And then we have advanced. Again, I'm not going to go into what all of these mean, but something that is important is if you are doing policy via ICE, then you do want to allow AAA override. And what that does is it allows radius change of authorization to be pushed down to a client. Well, actually pushed down to the controller. So like when a client authenticates, if you need to change the VLAN once they do authenticate, you would do that via ICE and ICE policy, and you wouldn't want to use any local policies you might have on the wireless controller. Right? So I'm going to close this out and not save it, but you can see yesterday I created a tap profile. So now let's go to the policy tag. All right, the policy tag, I'll just pull up the one that we did yesterday. All right, remember the tag is what gets associated to the AP. All right, so here's our WLAN profile. We created tap WLAN, and like I said, we're going to use the tap profile. So now, just like I showed on the PowerPoint, we're pairing the WLAN profile and the tap profile. So let me click the checkbox. So now the next one, it's not just one WLAN per policy tag. I had 3 others. So if I wanted to do now the lab WLAN, all right? But like I said, it's really the same profile as the tap profile. So I'm going to reuse the tap profile. Now you see I just created one profile, mapped it to 2 different WLAN or SSIDs basically. And then the last one we'll do is the guest. So here's the guest profile with the guest SSID. And we're going to go to the policy profile, but in this case, I'm going to use the guest policy that I created. So boom, there's everything now that is associated. So I'm going to update and apply to the device. So now, if I were to go to the policy tag, you see here's all three SSIDs and the associated policy. So now the next one is the AP join profile. All right, so we're going to go through the AP join profile. This will be one of the last ones that we go through because everything else is pretty in-depth and complicated. There's a lot of rules, but all right. So you always have to name profile. MSS configuration, you're not really going to change that. If you didn't want to change the cap WAP, well, actually, I apologize. So this is where you would configure the high availability pieces. So for your APs, if you had a primary controller and a secondary controller, let's say in an N+1 configuration, and N+1 means that you have 2 controllers that aren't, maybe they're geographically distanced, and you can't connect can't connect them back to back on the redundancy port. You could define what your primary controller is and what your secondary controller is, and you would do that here in the AP join profile. All right. If you wanted fallback, you could enable it, and that means if the primary controller failed, your APs failed over to the secondary. When the primary controller comes back, those APs will swing back automatically. You may not want to do that because you may not want to incur a second outage. So this is where you would configure your backup controller configuration. There's advanced here, data encryption. So for the AP, this is how the AP will connect to the wireless controller itself. You have different, if you wanted encryption for EAP, you could do EAP TLS, authorization type, CAPWAP DTLS. You could pretty much do, you pretty much change this to whatever you need it to be. All right. Now you see something here, which is packet capture. And you notice this is AP packet capture. AP packet capture is for the legacy APs, like the 3700 series. All right, anything from the 3800 series on up, they have what's known as intelligent capture. And intelligent capture is something that's run solely from DNA Center. It's configured from DNA Center. But what it does is it allows triggered packet captures if, let's say, an AP has a problem joining the controller. DNA Center will observe error messages being sent from the AP. It'll then start a packet capture to give more detail on what's happening. The same goes with a client. So if there's a client that's having trouble joining, through assurance, an automatic packet capture will be kicked off. And then when you go to look for that user's username or MAC address, that'll be part of the available data is an actual packet capture to see what's going on. Now, with that being said, I'm not going to configure packet capture, and you shouldn't either, unless you do have like 2700 and 3700 series APs on your network. We didn't remove packet capture completely from the 9800 series controller. All right, there is a way that you can run an on-demand packet capture, which also I think is a really good feature. Unfortunately, I don't have it up and running today, but I'll still show you where you would go to configure it. All right, so that was the AP join profile. I'm not going to go through the flex profile, but let's go to the site tag because we have to create that. So call it tab. All right, so the AP join profile is my tap AP join. Control plane name, I'm going to keep the same, enable local site. All right, so I'm not going to save this either, again, because we do have the tap advanced site tag that I already created. All right, now the RF profile, I'm not going to go in and create a different RF profile, but the most important part here that you can see is these are where those canned profiles come from. You have the RF profile per 2.4 gigahertz radio and per 5 gigahertz radio, low, typical, high. If we wanted to go in and look at what it is, I'm not a wireless expert, so I can't go through, but this is really where you would do channel assignments. And really where you get into this level of granularity is either if you yourself are a wireless expert and you're running your own site surveys, or you bring a site survey company in and they make recommendations on the best channel layout, radio resource management. So that's where you would really go through and configure this. Otherwise, you could just pick, you could pick a profile that's out there. And you can see there's some thresholds. I'm not going to go through all these. It's very in detail. But again, an RF profile is required for every AP. So with that, let's go through and create the RF tag. So, all right, here's your 5 gigahertz band. I'll do typical. I'll do typical. And you apply it to a device. Like I said before, I have a tap advanced RF tag. All right, so here's the last piece. You just saw that we spent a lot of time going through and explaining what parameters are configured in what profiles and how those profiles are attached to a policy tag. Well, now we get to the point where it's time to apply them to your APs, and you could apply them to all your APs, however you want to do it. Obviously, you'll have more APs than what we have in the lab. So all I did was I clicked on the list button down here, brought me to the screen. I checked the AP, then you go to tag AP. Now, all I do is I do the tap policy tag, the tap advanced site tag, I'll call that, and tap advanced. Now, I'm not going to apply it to the device here because I think I want to show some other stuff regarding the AP. Not that it's going to go down, but we know how the demo gods could be, so I'm not going to chance it. But at the end of the day, I did push these policies down, and you can see here's the policy tag, the site tag, and the default RF tag. All right, so once I click apply, the controller pushes it down to the AP rejoins, and it has all of those parameters ready to go, and it's advertising. Okay. So are there any questions on the modular profile and policies on the CAT 9800? Okay, great. Hopefully you saw from this part of the demo that it is actually, while it's the same amount of configuration as you would have on a wireless 3504, but it's more streamlined. And honestly, if I wanted to go then and look at it, I don't have to launch the wizard every time. I could go to the WLAN section, under configuration, tags and profiles, WLAN. Here's everything that I created. If I want to click on it, here's all of the settings that I just created. All right, so that's why we created that wizard. All right, so I did mention something during the configuration during the policy profile about application visibility. Well, if I look here, there's a lot of configuration in here. And where would the application visibility be? You may see it, but it actually took me a while the first time. I'm going to do a search for application. That brings up where it's located. So it's under application visibility, or it's under configuration. And if I click on it, it brings me right to the application visibility screen. Now, I'm not going to go through how to configure AVC, but what I can tell you is it does require the configuration of NetFlow and NBAR, and you assign your interfaces to NetFlow, and then NBAR picks up traffic coming in from those interfaces, and it feeds it into your policy. So, like I said, the policy profiles are what's applied to AVC. And then once that's set up, as traffic is coming in, if you're looking for particular traffic, you would see hits, and you would see your policy. You go down to monitoring and look at application visibility, and you could do application visibility based on the SSID, the source type, direction, last 90 seconds. So just by doing a search for application, it shows me the two areas where it's located. Right. So next one, I think it's worth showing is the AAA and where we configure AAA here. This is the there is a AAA wizard. I'm not as inclined to use the AAA wizard here as I am to use my my site tag creation policies because it's pretty straightforward, right? You want to add a new radius server, you could add, a server. If you have multiple servers, define your server group. If you didn't have Radius, but you only had TACACS, you could add a TACACS only server. Like if you had ICE solely for device administration, you would define the ICE server as your TACACS server here. All right. When you go to the AAA method list, so we have set up for local login. Everything is done via ICE for us. Again, this isn't an ICE lesson, so I'm not going to go into ICE. But we have local login for the controller itself. That's the rad auth e policy. Type is login, group, because it's radius group based. So now anytime we try to log in, we have to authenticate to our Active Directory through ICE. But when you have clients who want to authenticate via .1x, and this is important because this is where I mentioned about that .1x in the again, in the policy profile, you would configure for client authentication, type .1x, group, and point to your radius. So whenever anybody tries to connect and there's .1x, or via .1x, they would be sent up to the ICE for authentication. And so then let's go down. You have to do the same for authorization. Once you're authenticated, you need to have privilege, right? So again, for the local box, we're using exec. We're going to the group radius group. But for clients, we're saying network because what type of authorization do they have for the network, and then the group type. So again, there's a whole other world once you get into ICE, but these are some of the simple things to get started. Okay. One other thing that I wanted to show you is the mobility groups. All right, so I'm going to go back to the presentation again. And when we talk about not having to forklift your environment, your wireless, we actually do allow roaming between our last generation of wireless controllers, specifically the 5520 and 8540 and VWLC. In some cases, the 5508 wouldn't necessarily recommend it, but it is possible, so you can play around with it if you wanted. But what we created was secure mobility groups that support IRCM, which basically is inter-release controller mobility. All right, and what we have here is you have your legacy controller. It must be running 8.8 at a minimum. The problem with the 5508 is the last OS it supports is 8.5. If you did want to set it up, set up a mobility group. You could reach out to TAC. They have a fully supported engineering release. But I think, as everybody knows, running engineering releases in production, you know, you may or may not want to do it. But essentially, what happens is we create a CAPWAP tunnel, just like we would to an AP, but we create the CAPWAP tunnel between the controllers. And through that CAPWAP tunnel, each controller is able to learn about each other's APs. So when a client maybe is on one of the APs, like a 2800 or 3800 that was deployed on your AeroS controller, when a client roams from that over to, let's say, a 9120 access point, but in the same environment, we'll be able to track that client roam, the access point that they left, and the access point that they showed up on. We're also able to synchronize radio resource management between the two controllers, specifically for that client, but also for the AP itself. And then most importantly is we would do a layer 2 roam. So, or I'm sorry, a layer 3 roam. So it's important to understand here is that, you know, it's assumed that the DHCP scope for your legacy is one DHCP scope. The DHCP scope for your new is a different DHCP scope. And then we can actually do a layer 3 roam from one access point on legacy to the new access point. And we allow that to be seamlessly. Now, if you had, let's say, two Catalyst 9800s um, that were deployed, let's say N+1, you could technically, you should create a mobility group between them, but because they're same platform, same iOS, you could do layer 2 and layer 3 roam. And the same holds true on AeroS. So if you had two 5520s, you could do a layer 2 and layer 3 roam. The only supportability here is it's layer 3 only when you're doing inter-release controller mobility. Okay, just do that seamless layer 3. All right, so let's look at that. And honestly, we're getting pretty close to the end here. I know we have about 9 minutes left, so we are finishing up here. From the mobility group, if you were to configure it, you basically go down to wireless, configuration, wireless, mobility. Something else that is pretty good is that it shows you the path to get to wherever you are on the wireless controller. So this is my controller's configuration information. This is my mobility group name. And then I have a peer configuration. So I actually am peering with a 3504 wireless controller. The wireless controller is 172.1620.100. That's the remote. And you can see that the status is up. So if we go over to the 3504, you see that we're pairing with the group name MPLS Lab that was on the 9800. We did have to provide a hash key, and we have secure mobility enabled. So that's up. So right now, that's all you have to configure for mobility groups. And then there's ways where you could do mobility anchors. We're not going to get into that. That's a little bit more of an advanced configuration, but there's a lot that you could do. So, you know, it's an important piece of the puzzle when you're thinking about how do I actually get all of my APs from one controller to another. The reality is you don't really have to. You could go and do a phased approach and swing APs over, and clients should still be able to go between APs with no issue, very seamlessly. All right, so we talked about that. So let's go to administration. Like I said, we're pretty much finishing up here. One thing that I thought was nice that our business unit put in is we put in a high-level best practice screen. And your best practice is basically configurations that we feel should be enabled or disabled, and did you do it? So in this case, you know, I didn't disable AeroNet IE. I could click on the plus sign, and it's actually going to tell me what this means. And then if I wanted to learn more, I could go out to the Cisco website. If I wanted to fix it, I could go and fix it now. And it would actually, well, I'm not going to fix it now, but it would actually go through and fix it. So we do that for everything or most things on in the environment. Security, WLAN with WPA2 or 802.1x. We don't want WEP, we don't want WPA, and it'll tell you about all of those. So then there's um, more for Apple devices, RF management. I don't have WLAN configuration optimized for Apple clients. You go and do that. So it's not extensive. It's not like 100. It's not 100 items, points to go through, but it gives you a good idea of what's out there. And there are more, so you could go through and look at more. It's just good to know that it's out there, and you should run through that. The next is the software management. All right, and I'll show you this, and then I'll show you this, where to configure packet capture, and then I'm going to leave off with one of the best parts for all of the CLI engineers out there is because we moved to iOS XE, that means we also have a traditional iOS XE command line, right? So from a software upgrade, it's the same as what what you're used to on the 3504 from a configuration standpoint. One of the major features that we integrated into the iOS XE controller is the ability to do hitless software upgrades. Uh, that's where if we talked about an N+1 controller configuration, so you might have an SSO pair, but then you might have a third controller that's not, obviously it's not part of the SSO pair. You could actually define that other controller, the IP address and the controller name. And then what happens is, as you go through and you start upgrading, you would upgrade the third controller. We would actually, before we do the AP part of the upgrade, we would migrate a certain percent of APs. We would look for the APs with the least amount of clients, and then we would try to migrate them to other APs, the clients. Once there's no clients or minimal clients, we would then move the AP itself over to the new controller and perform the upgrade. And you could do that in 5% intervals, 15%, 25, or you could do all of them. Now, again, this is straightforward. In DNA Center, we actually have a workflow to go through the upgrade piece. Another major advantage to DNA Center. With this, if we wanted to change, let's say from the default, which I think is 15, to let's say only 5% of the APs, I actually do have to go into the CLI for that. So we have smooth software maintenance updates, AP service packs. If you had to only do a software update to fix maybe a vulnerability on the AP itself, you would go out and you would configure that only here. So that's where I showed the AP software version actually has a fourth section to it. I think this one was .139. Let's say we released .145 that fixed an interval or a vulnerability. You would go and you could do that here. And you can see here AP upgrades per iteration, 5, 15, 25, or one shot. And then a device pack. So we talk about it a lot. A device pack is basically something that you apply the device pack to the controller itself when Cisco releases a new AP. So if we release a new AP, previously you'd have to go and upgrade your entire network. With this, you just update the controller, and then the controller pushes it out when a new AP comes online, like a new model. All right. Troubleshooting, you could look at your logs traditionally, like your logging buffer, you could look at on this screen. A lot of these are advanced, but this is the packet capture that I was talking about. If you wanted to add a packet capture on demand, and that's for any traffic coming to or from the wireless controller interfaces, whether it's an AP or client. You define a capture name, basically assign your interfaces, and it starts creating a PCAP file. And it allows you also to see in real time once you start. Unfortunately, I don't have traffic coming to because I don't have any clients. The AP is already paired. But if I did, then I would just click start and you'd start seeing the packet buffer fill. All right, and just the last thing. So I'll show you the command line, and that will be that. All right, here's your typical iOS XE commands. Show log. Looks really familiar. If you ever try to do that on an Air OS, it'd be a little difficult. Show IP interface brief. There's all your interfaces. If I wanted to look at the detail of the interfaces, show it. All my interfaces, gig 1, 2, and 3, CapWAP 1, mobility 1, and it gives you traffic stats and information. All right. If I wanted to look at maybe some AP specific, I could do show AP uptime. It gives you AP information. Show wireless device count. So if we had clients, you could do a quick count there. And finally, the mother of all configuration commands, you could do a show run and not just see your typical iOS XE interface configuration, routing, NBAR, NetFlow, but you could also see how your policy was converted to command line. I think that's really powerful. Obviously, we recommend using the UI or DNA Center, even more so. But if you love to do CLI and you want to create templates or whatever, you can do that right here. So with that being said, that's everything that I had. Finished at 12 on the dot. Are there any questions that anybody might have? No? Okay, well, the session was recorded.
Do we have access to the recording?
Yes, we'll be sending the recording out.
All right. Great. Thank you for the presentation. I appreciate it. This is John from Delaware City.
Oh, hey, John. Yeah, no, thank you, John. Yeah, we'll definitely be getting this sent out. No problem.
Thanks a lot, Jason.
Good job, Jay.
All right, everybody. Well, thank you again for joining, especially during this this crisis time. Hopefully, this was a little bit lighter than what you've been dealing with all week. So, thank you again for joining.
Thanks, everybody.
Have a great day. Appreciate it. Good presentation, Jason.